Good morning. That was really sad, guys. That was really, really sad. Good morning.
Good morning.
Awesome. All right, great. Don't worry, I'm not really the featured attraction. I just wanted to welcome you all to this first of 4 Cisco sponsored track sessions today. We have one more right after this, 2 more after the morning break at 11 o'clock. So I hope you can join us for as many of them as possible. We've got some great stuff. We're going to start off with our first presenter, Ifti Rathore, one of our lead technical marketing engineers, talking about ACI and OpenStack for NFV. We've got a session following on the new Cisco container platform, which is really exciting. I hope you can join us for that. And then 2 more sessions in the afternoon that are really going to be of big interest to service providers, telcos. So again, hope you can join us for those too. So without any further ado, Ifti Rathore, TME at Cisco, and OpenStack, ACI, and NFV.
NFV. Good morning again. I hope everybody can hear us. Actually, I can hear myself pretty good. So let's get started. There's a lot of stuff to cover, and what I want to do is I want to have at least 10 minutes in the end for Q&A. But please ask any questions if you want to ask me in the middle. We can always be interactive. It actually makes a little more informal. So what we're going to mainly talk about the NFV features. So NFV is Network Function Virtualization, some kind of a service insertion architecture, which is actually accelerating the adoption of OpenStack in the service provider market for large organizations like banks that actually have branches that want to come into the centralized data center, and they want to process on those those flows and do different things, authenticate, NAT, all those different things. So I will talk about a little bit about ACI, because of course, if it's about ACI, we've got to know what it is. A little background on our Neutron plugin, and then I will jump right into the NFV. So starting from the ACI, what is ACI? So ACI is basically, I would say, a next generation SDN style platform, where we actually have a whole policy infrastructure where we can define our policies, our tiers, our endpoints, and it's mostly a whitelist model, so nothing will ever talk to anything else unless we actually allow it. Endpoint groups are basically kind of like a neutron network. You can even configure it in a whitelist way where actually you have microsegmentation and nothing even in a single endpoint group will talk to each other, but by default it will. It's actually implemented with what we call the APIC, the Application Policy Infrastructure Controller. That controller is not a traditional SDN controller because nothing ever goes up to the controller. Controller only talks to the switches. There is no lookup or there is no forwarding definitions that you have to do in the controller. Everything within the ACI is a whole bunch of Nexus 9000 switches in a spine leaf configuration, and we never ever talk about forwarding. Forwarding is automatically done, internally it runs ISIS, and it will find your endpoint and forward to it wherever it is. It's completely location independent. So there is actually a mapping database that will tell the system where to forward the packet. And it could be multiple sites, it could be a single site, but we never define any forwarding properties in our fabric. We only define the policies that A can talk to B, or before when A talks to B, I want the service to actually go through a service graph, which means I want it to go through a firewall and things like that. So this is just a, basically a quick overview. So the first thing, it is the endpoint identity and location is completely decoupled. The endpoints can be absolutely anywhere, and it will actually forward it to the correct endpoint because of the location database. The normalization of the ingress traffic, depending on how your actually ingress traffic is coming in, it can be classified to be a part of a different network. There are many different ways of doing. There's NVGREID, there's the VLAN. What we have is multiple domains. In a physical domain, it could be just the port and VLAN. We know if it's coming from this port on this VLAN, it belongs to this particular class of traffic. It belongs to a particular endpoint group, which means it belongs to a particular neutron network. It can be classified many different ways, and it's completely location independent. Another thing is the L3 is fully distributed. Every top of the rack switch has an default gateway for the network it's serving. It's all on demand. So if you create a neutron network, you spawn a virtual machine somewhere, the top of the rack switch will automatically have your neutron router IP. So the packet will always go from the compute node to the top of the rack switch, and then everything is done automatically, all the forwarding, and fully done in the hardware, and it's extremely fast. Internally, it's all VXLAN, and it's actually hardware-accelerated VXLAN, so there is no penalty for that. And as I said, in the physical domain, you can actually have VLAN classification. You can actually use VLAN encapsulation to pass the packet to the top of the rack switch instead of bringing your VXLAN tunnel down, because sometimes these OVS may have some, basically some throughput issues because of the VXLAN encapsulation. So you can use VXLAN or VLAN encapsulation. And we have service insertion. As I said, any traffic can be passed to a service within ACI. Of course, Neutron, till we had the semantics for doing that, we couldn't do that. So now we're going to use that actually to show you how we're going to even do that Neutron. Any traffic that we have, we can actually have it go through a service, which is actually the service chaining. And since it actually knows every endpoint, the flooding requirement, there are no flooding requirements are removed, right? So basically, it gives you high efficiency. There is no hierarchical routers. Two endpoints can talk to each other. There's a contract. So when you create a router in OpenStack, it actually turns a contract. And it doesn't matter where traffic is going to where. It's a single forwarding decision, and the traffic will go to the other place. And it's forwarded using hardware. So so as I said, identity, location, and policy, they're completely decoupled. So, but what we most of the time is define policy. The policy will also define how to classify ingress traffic. Once the traffic is in, it actually belongs to a particular endpoint group, which we call EPG. The forwarding can happen as soon as the traffic gets classified, right? So, and then we have a mapping database that actually tells where the location of that particular endpoint is. They could be completely decoupled. So these are just, I'm quickly going through it. If you guys are more interested, you can come to our booth, and we have people that you can talk to if you have any deep technical questions. Integrated underlay and overlay, which means all the tunnels, you don't have to sniff the traffic to see what it belongs to. You can actually go to the ACI and it will tell you which VXLAN tunnel it is, which Linux port actually it is using, like which VETH port it's actually using on the Linux, that VM, where is it attached, what the IP, what the MAC, everything you can see that is going on in your OpenStack cluster just by looking at the APIC. So that's basically ACI, just a very quick, ACI is like a very, very advanced, like the forwarding plane, it has a lot of properties. But this is just a quick overview. So now let's go to the Neutron plugin, right? So Neutron plugin is full replacement for Neutron data path. There is no Neutron data path that is actually, traditionally, we have a Neutron node that actually part of the Neutron data path. The metadata and DHCP comes from there. Most of the external connectivity comes from there. No, the packet will go from compute node to the Anycast gateway on the switch, and it will be forwarded. It does not matter if you're using floating IPs, you're using SNAT, or you're using traffic classification. Everything is done within ACI. It is from compute node The DHCP is served locally on every compute node. The metadata is served locally on the compute node. The L3 is done locally, every on the compute node. Nothing ever goes to the Neutron server. So it's basically centrally managed underlay and overlay by the plugin itself. And you have full visibility in the ACI. It allows you to basically, it's an ML2, so you can actually mix and match. If you want to use just regular Open vSwitch plugin on some nodes, you want to use SRIOV through hierarchical port binding, absolutely everything works out of the box. Nothing is required on the SDN plane. You don't have to go mess with the SDN plane, except just giving the plugin the IP and certificate for your APIC controller. And that's, so why would we use it? Well, as I said, it's a full Neutron data path replacement. We do everything distributed on the compute nodes, and this between the compute node and the top of the rack switch in the ACI. The floating IP NAT is also distributed. Nothing ever goes through the Neutron node. We also allow you to do NAT on the edge, which some people like to do that, but it may be phased out. Hardware accelerated forwarding allows you to do service chaining because that's part of the ACI. You can actually insert services using hierarchical port binding, or you can use the SFC API from Neutron now to actually do that. Operation and telemetry, we manage both underlay and overlay. It gives you an extra security and also a lot of telemetry. So we have, for example, if one of the agent dies, the ACI will show you that health score is down. Somebody pulls a cable out, it will tell you that health score is down. It will actually tell you why this particular virtual network is not forwarding traffic. You can actually go and follow the fault chain to a physical fault, which is extremely difficult when you're actually managing your own overlay on top of a third-party underlay. So, and it allows you to use different hypervisors. You can bring them into the OpenStack by dragging and dropping, or just with API. You can have a VMware VM bringing in. You can have actually a container talking to it. Within ACI, anything can be talked to anything, as I said, because the location and type independent classification rules. So anything can be classified to belong to an endpoint group. It does not matter if it's a VMware VM, it's a bare metal machine, or it's some third type of traffic that we invented. We can always find a way to classify it to a certain endpoint group. So endpoint group is a Neutron network. Within that, we have bridge domain, which bridge domain is basically the subnet that we create just so that you have. So, and one more thing I just quickly wanted to mention is we also have what we call group-based policy. Group-based policy allows you to, instead of having what we have on the right hand, the Neutron network model, where you have to know what a router is, what a network is, what a subnet is, you can define tiers, service A, service B, kind of like it actually inherent in the ACI. And then you can, using that whitelist model, you can say, service A can talk to the internet. When you say service A can talk to the internet, when you add another machine or VM to that particular group, it will automatically have a floating IP. So all those things are automatically orchestrated for you. If you say it needs to be behind a load balancer, it will automatically be provisioned for you. So the group-based policy allows you to do all those things without having any knowledge of the network. Something like the new address scopes, right? Somebody goes, manages some network manager or network administrator defines the address scopes, and after that, every time you create a group, basically a subnet gets carved out of that, and it takes care of everything for you. You never have to know anything about network. Another thing is, this is how we use it, basically a simple diagram, but you can actually go to the read the doc/group-based policy and get more information about it. We have little time, so I'm just gonna, we have basically group-based policy CLI that you can orchestrate everything with. We also, when you install group-based policy, a new dashboard extension, policy extension comes in. You can define everything. You can deploy whole multi-tiered applications using this, and everything that you can do from CLI can be done with that. And also you get the heat extensions. So if you use heat, you can still use and deploy group-based policy. Offlex is what we use to actually bring the policies, because when you create a network, you create security groups, you create all those things, they get pushed to the ACI as policies. When a compute node receives a VM, our agent goes to the ACI and says, I want all the policies for this endpoint. Those policies get programmed into the OVS. And so that is an open protocol that we use. Anything can connect to ACI and ask for a policies for endpoint as long as it's implemented Offlex. We're going to be using this a lot in the future, because when we have something that's ACI anywhere, you can actually extend ACI just using the Offlex instead of using anything proprietary. So basically, just a recap. You can use group-based policy, or you can just use Neutron API. Your troubleshooting, visibility, many different hypervisor security policies. You can also use security groups. Security groups are not done via IP table. This is an older slide. It's now done using basically the OVS, because now OVS actually has stateful, it has con tracking, so we moved it to OVS, and actually it is defined in ACI instead of having to be in an IP table rule. NAT, SNAT, and basically distributed L3, L2, the ones that I already talked about, and hierarchical port binding. As I say, everything is a domain. We have physical domain, which is anything that is coming in through VLANs or connected outside can be classified. We also have what we call the VMM domains. VMM domains are another way of classifying things that actually are virtualized. So we have VMM domain for OpenStack, where you can actually see all your operational data, right? You can see all the networks that you have created, all the compute net that you have. You can look at all your workloads per network, per compute node, and it'll tell you the full operational data about it, which network it's connected to, which port it's using on the Linux, which and everything that you see here. And the health scores. As soon as you go below 100, you know something is wrong, and you can actually go to the faults and see what is wrong. Somebody pulled a cable, an agent died, things like that. The same thing, as I said, when you create a network, the ACI will create a project, which we call a tenant, and within that it creates the endpoint group, which is actually representation of that actual Neutron network. And you can also look at all the data from the Neutron network. This is what ACI is seeing. I have traffic coming from this particular port on this VXLAN tunnel. It'll show you everything. The one that I showed you before, the VMM domain, that is what should be. That's what Neutron is telling us. This is what Neutron is telling us. And this is what we see. So you can actually look at the operational running data, or you can look at what it's expected. So that gives you a lot of visibility. So all of these things we already have delivered. So we are up to Pike, hierarchical port binding, SRIO integration, anything that can do VLAN type will automatically work because of the hierarchical port binding. We can actually have multiple FISNets where some are Offlex, which is our internal tenant network type, and VLAN, and others we can mix and match them. V6 support. We also give you a way, if you're using, as I say, you can actually hand your traffic to the top of the rack switch using VLAN encapsulation, which is extremely fast in Open vSwitch. You can reuse those VLAN pools per rack or as you want to do. So you do not have that 4,000 VLAN limit. You can scale it to as much as you want. We have container support. We support JujuCharm. We support the Red Hat OpenStack platform. And then we also support people making their own. We have a separate type of arrangement with them where we actually can support their platform, but we get involved much earlier if they're going to deploy their own cooked version. We do SFC, container, Neutron trunk port. All those I'm going to go through, so I'm not going to go through that much. What we're going to offer next is basically QoS, L2 ports, more troubleshooting, more enhancements, copy service from a VM endpoint. Right now, you have to do it from the switch port. Queen support, and of course, VPP is coming very soon natively. VPP is another very fast user space switching stack from Cisco. So this was just a quick overview for everything. So now I'm going to get into what this is all about, right? So NFV is basically the network function virtualization, or basically service. It's kind of a multiple things together. We use Neutron trunk port so that we can actually use the same pipe for multiple customers depending on the segmentation ID. We segment those customers. You can just using Neutron trunk port. The SPI network is another new thing which actually allows you to create an SPI network using Neutron. The benefit of that is actually using an SPI network, you can do BGP peering with ACI from a VM, which means you're actually all of a sudden dynamically advertising your routes outside. As you're building your virtual network, you can peer with the rest of the world. That's part of the requirement for service function chaining. Then SFC is the service function chaining API from Neutron. We have fully implemented it using ACI. ACI has something which is called policy-based redirect. Not policy-based routing, we call it policy-based redirect. And it's multi-node, which means you can insert as many bumps in the wire during, and basically create the classifier and then create the service chain. It will automatically start passing that traffic through those service VMs. So you spawn VMs. I'll actually go through into more detail. And then in the end, OVS DPDK. OVS DPDK is a fast switching plane that a lot of packet core and the NFC users like to use. So added the OVS DPDK support. So start with the Neutron trunk support. So what is Neutron trunk support? Neutron trunk is basically an API for actually creating a trunk port within a VM. Instead of having multiple networks connected to multiple NICs in a VM, you take a single port. Then what you do is you create subports. You create more ports. You make the main port a trunk. And then what you can do is the subports that you're creating on other networks, you can add them as segmentations. Like this is VLAN 20 that connects to network C. This is VLAN 10 that connects to network B. And then what you can do is you can, in the VM, you can create those sub-interfaces, and those sub-interfaces will automatically be forwarded to those networks. So it's basically makes it easy. So you create a port, then you make that port trunk, then you basically create other subports on other networks, and you attach them to that particular main port using segmentation IDs, which means VLAN 10 is this network, VLAN 20 is this network. And so this is basically the main semantics for it. This is an example of it. This is what it does. Like we have the green, which is the parent port. We basically do a Neutron port create on the green network, and then we can actually create the subports and attach them to the green network by specifying, for example, the segmentation ID is 20. So as soon as segmentation ID 20 means if you create a subinterface in that instance, it will automatically connect you to the network C. So that's basically Neutron trunk port, a way of actually creating trunk on a single Neutron port. And then the second thing is the SPI network. SPI network is a network that allows you to, within ACI, we have what we call L3 out. L3 out is a layer 3 entity that will connect all the virtual forwarding plane within ACI to the external world. Most of the time, BGP peering is needed when you're actually going to the external world. So you can actually have a virtual machine spawn that will peer with that SPI and will advertise its routes, right? So we basically can create the L3 out automatically by just doing the net create. So we can create the net create, and we can use an existing L3 out. We can also have it automatically create an L3 out, depending on how your requirements are. Do you have an external leg that is actually going to a particular physical port? You can also do that from there, but you have two ways of defining. One, you can use an existing entity on ACI or have it actually created. This allows you to create a virtual machine and basically use these IPs to peer with that L3 out and start advertising your routes that you're building on the fly for a customer. So this is basically the example of creating the auto L3 out without having to actually specify an existing L3 out. It will create one for you. And basically, this is showing when you actually create the peering networks, all switches get their profile for peering. We're going to have something which is called auto one. So, and then the third is the service chaining. Service chaining is also a Neutron specification that allows you to create service chains. So I'm going to run through it quickly, but you can always come to me and I will give you a full demo. I actually have a full demo running, right? So what we do, every service VM would always have 2 ports, right? So we create 2 Neutron ports, one on one network, one on another network. We spawn a VM with 2 legs. We take those ports and we say Neutron port pair create. Neutron classifies those as a port pair. You can create a port group. Then you create a port group with multiple port pairs that will actually be stacked in parallel and load balanced. And then you can have multiple port pair groups and create a service chain by specifying what we call a flow classifier. And that service chain will automatically be instantiated, and anytime a network traffic goes through those things, depending on the flow classifier, it will automatically be redirected to those service VMs, and you will see them coming in into the ingress port, and you can then have IP table send it, or you have a firewall, whatever. However you use, whatever the function, it'll actually insert that particular VM in the middle of the data path. And that is what we do. We support the API full. It depends on your vendor if they're going to do a CLI or they're going to allow you to do it through dashboard. But we fully support it. And what OpenStack orchestrates everything, and it gets pushed back into the ACI. No manual intervention required. And then basically we map into a service chain. Within ACI, it's called a service graph. And when you add, so creating a service chain is basically creating the network, creating the port pair, all Neutron command, Neutron port pair create, Neutron port pair group create, Neutron classifier create, and then Neutron port chain create. If you want to add more you basically, in the end, you can use port chain update, and it will automatically insert or remove bumps on the wire. So you can update an existing port chain by using the update port chain. So, and then in the end, if you have multiple port chains, you will see that it's actually the service graph gets modified with multiple bumps in the wire. And I'm quickly going to go through the use case that I was showing. Is basically you have people coming in from branch. They are going to, so the VPN here, they go through this transit SPI, which is the provider's data center. Here we can define these port pairs. This is a single port pair. This is a multiple port pair in a single group. They get parallel and automatically gets load balanced. So we have these 3 services that we can insert in the middle. And then this will go out the NAT. This is where you do peering. This is where you do BGP peering. This is where you do BGP peering. This is going to be a Neutron trunk port so that you can have multiple branches or multiple customers using the same. So, and then basically we have OVS DPDK support for doing fast data plane forwarding within the, basically within the switch, soft switch that is sitting in the hypervisor. Once anything is passed to the top of the rack switch, it is automatically hardware forwarded, so there is no efficiency needed. But a lot of service providers say they want to use OVS DPDK because they want fast forwarding within the hypervisor data plane. So, and this uses hierarchical port binding. It's basically regular Neutron hierarchical port binding. I can describe it to you if you come there to my cube. I can give you a full demo. Any questions you have, make sure you can feel free to contact me. And any questions that you have, I can take them now. This would be on the top of the rack. The SPI is created on the top of the rack. And what happens is, as soon as you create that SPI IP appears on the top of the rack switch automatically. And then your VM can peer with it, right? So basically, you're running Bird or some type of a stack that is doing BGP. It can peer with the switch that it is connected to and advertises routes there, and they automatically gets advertised through ACI to the external world as you configure your networking for the external world. So it's all automatic. The BGP is configured by network guys because I have no idea how to configure it. But I know how to configure Bird to advertise my own routes, and it just works. And then you go to the switch and say, show IP routes for this particular VRF. You'll see all the routes that you advertise actually populate on the switch. You can go to the external router, and you'll see actually getting pushed to the external router. So.
But it's not on the component on the hypervisor?
No, not on the component on the hypervisor. It can be, but it's basically mostly we use it to peer with external world. You can peer with another VM if you want. It's not that's not a tough. It's not a hard requirement, but that's most of the time it is. You can peer with any endpoint.
Yes, I can understand that you can peer on multiple VLANs coming from a server that each of those is connected to multiple VMs, but the peering session starts on the top of rack.
Yes.
Start on your off-flex component on the hypervisor.
No, the hypervisor VM will peer with the BGP. So it will be so that, yeah, so what we're peering with is actually in the top of the rack switch. Yes, that is correct.
Any?
The classification capabilities on the hypervisor, how is that done in
SRIOE?
SRIOE?
So the SRIOE will be VLAN and port, because the SRIOE, there are only two things, right? One is basically which port this NIC, SRIOE NIC is connected to. And then what SRIOE does, it basically, every network turns into a segmentation ID. So we have VLAN and port. That's how it will get classified to a particular Neutron network or an EPG.
On the hypervisor, what are the classification capabilities? How deep can you classify?
On the hypervisor, it depends on if you're using OpFlex, then you can just use any ACI classification policy. With SRIOEs, of course, we are only limited to NIC and port. Yeah.
We're actually going to get this. We're going to do this.
Is this applied to the branch office? And if applied to the branch office, how big of the stack have to implement? I mean, so, how many CPUs, resource for the CPU devices?
On the branch side, of course, there's nothing, right? Because this is within the data center. But it's usually would be, I would say, to do basically run a VM that is peering and everything, 2 CPUs, 2 vCPUs, maybe 16 gig of RAM should be enough. But it depends on how compact you can get. A VM running Bird does not require too much. Especially the BGP peering is just a simple TCP session. I just connect with the TCP and just passes some packets, right? It's not really that demanding.
Well, I just want to understand how big of the OpenStack components, loaded on the CPU devices.
But just VMs. Basically, they're just regular VMs. Everything is done in the ACI. So you have just regular OpenStack virtual machines, right? Mm-hmm. If you're running a service, then the service will tell you how much CPU you need. For us, basically, it should be able to run BGP peering session. That's the only requirement. Everything else is, you send the packet to the top of the rack switch, it will take care of everything for you. So it's basically VM, how many CPUs and what you need is completely depends on what you're going to run on it. Some people run like full authentication stacks and stuff, so they need a larger. We do not have any specific CPU requirements. Basically, you can even do it with a Cirrus VM. It's very lightweight, the requirement for us.
Okay, thank you.
Anybody else? Well, I think you've answered all questions.
And plus, I'm going to be, we have Cisco booth.
Come down to the Cisco booth in the expo if you have any more questions. Ifti, I think you're there later today.
Yes,
and
I will be.
We've got a team down there all day. So thank you all for coming. We have another session starting up in about 10 minutes. So hope you can stick around for that. It's going to be on our new Cisco container platform. And we'll see you in just a few.
Yeah, and if I'm not there, I will definitely be there tomorrow morning at 9. That's my booth duty.
Oh, okay.